coming to listen to what I hope will be an interesting and exciting topic presentation on artificial intelligence. Given the interest from last night, I have a feeling that a lot of people are very interested in AI and hearing about some of the possibilities. If anyone was at Brian's presentation last night on some of the malpractice issues, there is no videos. I really wish I embedded some videos of some of the pop culture, but I missed it. You're going to miss some of that with my presentation. But one of the goals of what I want to do today is AI it seems like it is everywhere. I know that there's breakout sessions and panels today that'll be covered. And I just want to provide a little bit of background and set some context to make sure that everybody gets the most out of those conversations as you're having them. And before jumping into this, I'm just curious, who is using ChatGPT today? Like, who has it? Let me just say that. I got 2 hands back there. I like that. So I'd say that's like 80% of the room. Who uses it every week? Like weekly, part of their cadence, they pull up ChatGPT? Okay. Who uses it every day? Well, that can't be right. One person uses it every day. Okay. Yeah. So anyone? So no one has it pinned as like their go-to tab ahead of Google search is to go to ChatGPT? Not yet. Okay. Interesting. Good deal. We're going to talk a little bit about ChatGPT. ChatGPT is not the only player in the AI space right now. And as we go through the slides today, DALL-E is going to be generating a lot of these images. And so anything where you see DALL-E in the bottom right-hand corner, and that is like a generation, it's a product that is provided by OpenAI that helps you generate images. So anytime you see DALL-E in the bottom right-hand corner, that picture is generated by ChatGPT through a prompt. And I would like you to look closely at them and see if you can spot anything that looks kind of inconsistent or not maybe what a human would create as we go through the deck. And I'll give you a tip on this one here. So this is an image of the evolution of artificial intelligence. And if you look at the pedestals, you kind of have a mainframe. And then you have what to me looks like that Mac piece or the Mac computer that came out maybe 10 years ago. And then after that is the older looking CRT. So maybe if a human was creating this slide, they might reorder that a little bit to put it in sequence of time properly. So a little bit about me before we get too far into this. So I'm the co-founder of an AI services company called NLP Logix. We are based in Northeast Florida, Jacksonville, Florida. We've got about 100 folks on our team, and we are focused in building AI-enabled applications for our customers. So we don't sell any products. We are just helping our customers use AI to solve their problems. On the upper right-hand corner, that is me almost a year ago today, speaking on AI at TEDx Jacksonville, and it was absolutely terrifying. If anyone has gone through the TEDx experience, it was something unlike anything else, but it was fun and I learned a lot. I am from Fargo, North Dakota, so that's the logo of my alma mater, NDSU. So if I speak a little bit funny, a little bit Midwestern, that's my Fargo accent coming out. And I have a real interest in education. I love education. So I do teach a little bit at UNF in data science and Jacksonville University at data science. And our company has a strong relationship with Ed Waters in Jacksonville to help them bring out their computer science program. So this is what we call our NASCAR slide. The purpose of this slide is to just show where AI is today. And the answer is it's really in every industry. It's not focused on this area and that area. AI is really kind of cross-cutting. You can see some of these logos, you probably recognize a few, but it really is starting to be applied to any and every industry. And particularly in healthcare, this is our interactions in healthcare and developing solutions. And we kind of cut this slide into a top and a bottom to kind of tell the story for us. So the top of the slide is algorithms that we had developed for what we would call the clinical side of healthcare, where we had focused on building models that could identify tumor cells in a digital pathology slide, or identify melanoma of a picture, of a dermatology picture, or even looking at a MRI of the brain and identifying white matter hyperintensities. So we developed all these algorithms, and we have, some of these algorithms, believe it or not, are award-winning algorithms. They are, at the time, they were best in class. But we really struggled to generate any revenue from these models. It was very challenging for us to find a way to commercialize. And so what we ended up doing is we kind of pivoted our business to really focus on what we would call the administrative side of healthcare. And that is bringing automation into the back office, helping our customers be more efficient. If it's helping our customers process claims faster, capture data from medical bills, or digitize or transcribe audio files, anything that we could apply to the back office to help them operate more efficiently. That's kind of where we found our strength. And you know, our business, we're a bootstrap business. We don't have any venture money, no venture capital. So a business model that didn't generate any revenue for us, that wasn't going to get us too far. So we had to pivot pretty quickly to the administrative side of healthcare. So this is I want to tell this story. This is kind of interesting because this is a personal story about my wife, and it's kind of just the journey of us through healthcare this last, I guess you could say, these last 10 months. So, you know, my family has been very fortunate. We haven't had any real healthcare issues or anything. Me, my wife, my children, my sisters, my parents, everybody is really, knock on wood, they've been very healthy. And then last December 20th, this was a text message that my wife had sent me at 2:10 p.m., and you can see it's mostly gibberish. And she actually didn't even send it to me. She sent it to my aunt. And anybody who knows me knows I don't text with emojis, so clearly that couldn't be me saying what there. But this text was from my wife. She was sitting in the back of an ambulance in the parking lot of my daughter's school because she was having a stroke. And it was, you know, it was kind of wild. So I'll give you the end cap of it. So the end is she's great. The outcome was perfect. She's very healthy today. At the beginning, though, she was very fortunate. She was helping with a third grade Christmas party. And she was walking out of the school at 2 o'clock. And she was walking with another room mom that was helping with the party. And my wife said she got a little lightheaded, so she said that to the person she was walking out with. And the other room mom just happened to be a ER doc at the Mayo Clinic in Jacksonville. And she said, "You're having a stroke." And she called 911, and she wrote the time on my wife's hands just so she knew exactly when it started happening. And yeah, that kind of set off I guess I would say a 7-month exercise of going through the healthcare system. And for us, you know, been fairly healthy. There's a lot of new experiences for me, new experiences for my wife. And it definitely had its ups and downs. It wasn't, we got a good outcome, but we definitely had our ups and downs. And just so, you know, some of the ups and downs, I guess I'll get to, but she had a hole in her heart. I'm sure most people know this, but most people are actually born, everyone I think is born with a hole in the heart. And then 20% of the time that hole doesn't close. And so what happened to her is they believe they had a blood clot that started in her leg, and it had gone up into her heart. And I guess usually in the heart it would break that blood clot up, and that's normal. But she, I guess, they think got unlucky, and she was maybe lifting something out or coughed or was doing something. And at that moment, that blood clot jumped through the hole, that little hole in her heart, and it went up into her brain, and then that's what shut off part of her, caused the stroke. So it was quite an experience. And then, you know, some of the ups and downs, this was this is one from my wife's view, which I find really interesting. So after she was discharged, we got home on Christmas Eve, and she had her follow-up with her primary care on the Tuesday after Christmas, I believe. So it was a couple days after Christmas. And her primary said, man, I'm looking through the discharge, and are you sure you had a stroke? Because it's not obvious to me that you had a stroke. And of course, to us, that was kind of wild because, she had, all of everything that happened. It was like, wow, okay, that's kind of that's a confusion and concerning. And it took us down a path of her coming back in and getting more MRIs and more tests. And I don't know if this is normal or not normal, but she ended up having a spinal tap, and she saw an ENT for some different reasons. But we were 3 or 4 months after the stroke, and it's like it didn't feel like we were really making any progress, and it was kind of frustrating. So we ended up changing hospital systems to kind of get a second opinion. And one of the things when we change hospital systems, of course, me, super nerd, background in medical imaging, at least from some of the work we'd done previously. I had every one of our MRIs, every CT, every test we had, I had it on a DVD. And we brought that to the new facility, and when they had done one of the diagnostics, they put the TEE, which as I understand it, it's a thing that goes down into your throat, and it kind of takes a picture of your heart from your esophagus, I think that might be right. And they did that to try to see if they can find the hole in her heart. And that right there is what it's supposed to look like, that flap at the top. That would be the hole. And so she had that TEE done, and when we were getting this for the second opinion, the cardiologist was talking, and he was saying, yeah, I see the TEE, but nowhere in here can I see the hole because they were off. The imaging was done not looking at the thing that it was supposed to be looking for, the exact thing that it was supposed to be looking for. So, we were going in, or she was going in to get that hole fixed, which is actually pretty neat. They stick what I would describe as it's like a toothpick, like a metal toothpick that has an umbrella that pops out of each side, almost like a cocktail umbrella, and then that pulls together. So they would stick that toothpick through that hole, deploy the cocktail umbrellas, and then suck them together, and that's gonna lock that's gonna keep the hole in place. So what he said is, he's like, look, I don't know, we really don't know if there's a hole. And the best we can do is just go in, and if there's no hole, we'll just call this a bust and try something else. Turns out there was a hole, and they got it closed, and everything ended up good. But a little bit of a frustration. And then I would say this last one to me was something that was incredibly crazy. So when you have that stroke and you're in the ER, and my wife's got the time written on her hand, it's because if you don't get the clot buster in time, then the symptoms might not be reversible. So there was this wild moment when we were in the ER, and I had only been there for maybe 20 minutes or a half hour. And when I got there, I would say that everybody I think knows the droop of the face. So my wife, the side of her face, I would describe it more as like melting. It was very. She was really in a tough spot, and then she went for an MRI, and I stayed in the room, and she comes back, and it was like everything is great, like facially everything had totally resolved, and it was like, wow, this is fantastic. And the only problem was she had what she described it as double vision, but she said it was actually like if one eye was seeing everything sideways and everything else was normal. So not quite double vision, and that was, obviously very concerning. And the doctor it was, a TV was wheeled in, and the physician was on the television screen, and he was saying, which is crazy to me, because this is probably literally the most important decision my wife has ever made in her life. He says, I guess you could use a Matrix reference. It's, you get the red pill or the blue pill. this will probably resolve on its own, and then everything's great, you go back to normal. Or you could take the red pill, and there is a 5% chance your minor stroke is going to be a major stroke. And very, very, again, like I said, probably the biggest decision my wife had to make. And I was, if it's me, I was like, I'm not really I am a risk taker, but not with my wife. So I would say, I don't want you taking that pill, I think but she was with it, and she's a pharmacist also. And so she wanted that. She knew, she knows enough about the drug, and she's like, let's go, let's do it. And then, of course, we got the outcome we were looking for 7 months later. But really for me, it was just, it's so interesting because I look at this, and it's like, I get a little frustrated because we've got so much great technology and so much capability. And, I look at this, and I just feel like that whole experience from, maybe some QC on that chart as far as, hey, do these notes match what happened? On the imaging front, we have technology on imaging to help us understand what we're seeing in these reads. And this technology is to the point where it's really, really good. And, when it gets to this, the communication of this will probably resolve on its own, that's a major decision. And I would like to understand this 5% chance. Is that conditioned on everything you know about my wife, her age, her, what we were seeing, her demographics, or is this just a general population metric? So I think healthcare it's in a spot where it would be great to have an AI co-pilot, something, and I don't just mean on the provider side, I also mean on the patient side. When we were switching healthcare facilities, I had all that imaging. I would love to be able to put that into an assistant to help me get a reread on what was or wasn't in all that data. So I'm excited for this. I think there's a lot of opportunity coming. So now we're gonna, I hope that wasn't too much of a downer, but I feel like it was to me, it was kind of eye-opening with what we hear about what's happening versus what you might experience today. But there is no doubt about it. There is a tremendous amount of hype around artificial intelligence right now. And I hope everybody by now has picked out some of the spelling errors. Yeah, maybe you didn't, but Dolly is not great at spelling. This is not me that is misspelling these slides. So look, artificial intelligence has taken over marketing. It is transforming healthcare. I guess we can debate at how quickly that's happening. Cybersecurity, communications. It isn't just coming to supermarkets, it's already there. And then probably my favorite, when decisions seem impossible, it's time for AI. Can we feel the expectations rising, the hype? And then I kind of like this one, how to live longer and grow rich with AI. I got to say, I think we maybe need to temper some expectations, at least just a little bit. And then, of course, you have OpenAI, which is really a revolutionary company doing amazing things. The CEO there is Sam Altman. He comes from Silicon Valley. He's got a venture capital background. Worked at Y Combinator, a pretty, honestly, probably the best accelerator of the last, 20, 30 years. In his mind, AI is going to eclipse the agricultural, industrial, and internet revolution all put together. Amazing. Sundar from Google says AI will be more important than electricity or fire. That's one of the core elements, right? Earth, wind, and AI. Is anybody? I don't know. But these guys have a vested stake in this, right? Like, this is not independence, right? These guys want this. They are selling these services. There's a lot of money here to be made on being the winner in this area. And it's unclear how many winners they're going to be. This to me is like, they're fighting over revenue that could compete with, basically the internet, winning search, right? What did winning search mean for Google? It means $80 billion is what winning search means for Google. So these guys are fighting over some major, major things. So look, right now, everything feels like it's moving up and to the right with AI. Like all there's going to be is growth and success. But it's not all that clear if that's the future we're going towards. So this is Sam Altman, again, the CEO of OpenAI. He went in front of Congress a few months ago, and he's saying that, you know, we need to regulate. It's critical to prevent and mitigate some of the negative impacts of AI. Now, why would Sam say this? Again, they are fighting over an enormous revenue opportunity. And if you haven't, maybe you have. If you've watched, if you know who Bill Gurley is and you've seen his YouTube clip on All In where he gave a 20-minute presentation on regulatory capture, if you haven't listened to that, I highly recommend you do, because it touches on telecom and healthcare and how when you have the lead like OpenAI has right now, one of the best things you can do to put up the wall is to keep the disruptors out by adding in gates. How can we make it harder for new people to get into this business to compete with me? And adding regulation, having Sam say, hey, you know, you can do bad things with this. Let's not let that happen, but let's trust us that we're not going to do that, but let's not let anybody else get into this game. And I would say, too, that there is a growing interest in thinking about the long-term viability of large language models, not from a capability standpoint. They have amazing capabilities, but the cost of them. You have, I think it was the Wall Street Journal last week reporting on how Microsoft's Copilot, GitHub Copilot, which is their large language model for developers, loses $20 per month per user. And we pay $20 per month per user. So, you know, it's $40 to operate that on a per user basis. There's some speculation that ChatGPT is losing money every time somebody enters a query. So these models are massive, and I think it's actually really hard to put, you know, to give the right context for really how big they are. They're hard to create, they're hard to train, they're hard to operate, they're hard to enhance, and they're expensive. You know, I don't know. I think this is something we got to keep an eye on to see how this will play out from a cost standpoint. And if you look at, you know, you look a little bit at the hype cycle again. So this is the search interest to some of these technologies. Some technologies recently that have been, you know, all the hotness, all the rage. Clearly right now for artificial intelligence, we're at an all-time high of interest. And you know, if you look back at, say, blockchain or crypto, or even the metaverse, I really don't get the metaverse though, so I have a harder time picturing that. But with crypto and blockchain or NFTs, like there was moments where when that was at 100% all-time interest, like it really didn't feel like it was going to come down. It felt like there was a fear of missing out. Boy, why didn't I get into Bitcoin then? Or why didn't we get into FTX? Or what, you know, blockchain for logistics that was going to, you know, solve a bunch of problems. And those really never materialized. But then you have technologies like 3D printing or the Internet of Things, and those obviously had their ups and downs, but are continuing to grow. And to me, you know, no one can pick the future of where AI is going to go, but I do think, in my opinion, it's clearly going to be more like 3D printing or IoT, and probably even bigger. You know, probably even have a much bigger impact, but there will be ups and downs, you know, absolutely. I don't think we can have the hype we have today and the expectations about being more valuable than fire and electricity and not have some people that are disappointed or not have it not work as we expect for some use cases. That's definitely going to be happening. And this to me is super important. Like, to me, this is important for my business personally. So Andrew Ng is a thought leader in this area. He co-founded Coursera, Stanford professor. He ran Google Brain for a while and all kinds of great things. He's really a thought leader. So this is how he sees the world in terms of value generated by AI technologies. And this is how we seize the world. So I got to say that this is meant to demonstrate relationships. You can see generative AI relative circle-wise. It's bigger than reinforcement learning, smaller than unsupervised learning, but significantly smaller than supervised learning. Supervised learning is what, ChatGPT came out November 31st last year. November 30th of last year, supervised learning was what everybody was talking about. Whenever we would say AI, we really meant supervised learning. Labeling things, predicting things, tumor, not tumor, hot dog, not hot dog, whatever the thing is, everything is supervised learning. So even though generative AI today has all the oxygen, we really shouldn't forget about where the value is being created today, and that's really coming from supervised learning primarily. And in Andrew's mind, same with the next 3 years. I think the next 3 years, supervised learning techniques are so well understood, and we're getting very good at building and deploying and maintaining and enhancing supervised learning techniques, and there's a ton of value out there to be captured. Relatively speaking, generative AI there's gonna be more and more use cases, but relatively speaking, there's still gonna be a more value created from supervised learning. Even if there's more attention right now on generative AI, because that's where all of the hype is. So I thought that's interesting. I do, 5, 10, 15 years from now, this is probably gonna look very differently, and we might have another newcomer. Again, 11 months ago, Gen AI wouldn't be on here. So 12 months from now, what else is gonna be on here that isn't on here today? All right, so coming through the history, I think it is important, if AI just kind of like registered with you in the last 6 months, I think it's important to think about how we got to where we are here today. Because if you think about that and you understand the pace and how the landscape changes, I think we can have tools to think about what's likely to happen in the future. And again, the spelling, I spell better than this. This is great. So brief history, but it does go back 75 years. So the term artificial intelligence kind of coined in 1956. And the first chatbot, if you can believe it, was 1964. And then we got a little bit of a jump, and in 97, if some of you remember, Deep Blue defeating Kasparov in chess, which was kind of at the time, that was amazing. That was, if you think about the time when that happened, it really was amazing. Like, oh my gosh, it can beat us in chess. What else can this thing do? And there's a great anecdote actually about that match that they had, which was Deep Blue, which was created by IBM, which was basically an expert system. So they had chess experts, and they basically programmed what those experts would do in situations, and then they had search. So the AI at that time was a combination of expert system and search to kind of play ahead 4 or 5 moves and to see what led to better outcomes for Deep Blue. And the neat anecdote about that was that during one of the matches, Deep Blue, it hit a bug. It hit basically an error case. And the logic for the error case was, if I can't figure out the best move, I'm gonna play a random move. And so Deep Blue played a random move, which kind of threw Kasparov off. He was like, whoa, what was that? I wasn't expecting that. What is this thing doing? This is higher level intelligence that I don't understand. Kind of spooked him. And obviously, we know the result, that Deep Blue ended up winning that second time they played. But rolling it forward, 2002, we get Roombas. I still have a Roomba at home. Often forget to charge it and turn it on, but it's a different story. 2011, we get Watson. Remember Watson winning IBM? That was pretty amazing. And then finally getting up to 2020 and 2022, we're up in today's world thinking about GPT and ChatGPT. But some of the things that I think are interesting is they call that time in 56 and 97 kind of an AI winter, where there didn't appear to be a lot of advancements. It didn't seem like we were making progress, and AI wasn't, you would have this many AI researchers in the world, right? Like now there's this many people listening to a talk on it. It's just very different. But during that time, the theory for deep learning was discovered. And Brian had mentioned the godfather of AI being Geoffrey Hinton. Geoffrey Hinton was not the only one, but active in that time, really driving the theory, literally setting the stage for what's coming 40 years later. It's really amazing. So that theory that was created, it was only theory. We didn't have the compute and we didn't have the data to do anything with it. And then something wild happened in 2011, 2012, is some researchers, actually from Geoffrey Hinton's team, they realized that they needed to use accelerated computing, a different kind of processor than a CPU, which everyone would have in their laptops. They wanted to use a GPU because GPUs were really, really good at exactly the kind of math operations and had the parallelism that would allow the theory that was kind of worked on up to then become real. And because of that, NVIDIA, who was really focused at the time on graphics for driving displays, got into scientific computing and building toolkits that would help deep learning, which is the name to some of the algorithms that we use to build things like ChatGPT. So taking a closer look at that in the last 10 years, September 30th, 2012, I would say that was the day where deep learning entered the vernaculum. And it's kind of interesting, if you look at the pictures on the right, those are 256 pixel by 256 pixel pictures, very low resolution of basically cats and dogs. And that was the benchmark that was used to measure progress of image classification. And it's like a toy data set. It seems so silly to think about that now. But that was state of the art 10 years ago. That was the benchmark, that's what we did. And then AlexNet is a very specific type of model, kind of like GPT is a specific type of architecture. AlexNet was actually pretty simple, but it was GPU accelerated, and it was leveraging deep learning, and it absolutely crushed all benchmarks at that time. So this is for that image, for that data set of cats and dogs and squirrels and boats and houses and motorcycles. This is an annual challenge that was run where basically the algorithm had to pick a picture and had to pick the label that corresponded to the picture. That was the predictive task. And you can see in 2010 and 2011, kind of before deep learning, the top 5 error rate, which is what percent of the time did the algorithm not pick the label that was in the top 5. The error metric is 28%, 26%, not real good, not very good at all. And then in 2012, with deep learning and AlexNet, they almost shaved that error metric in half to 16.4%. And you can see the benchmark for a human is 5%. So that is how good humans do. And so between 2012 and 2015, 4 years' time, the models got a little more complex, and we've already beat superhuman. We're already at superhuman levels, okay? And then by 2017, the challenge is over because there's nothing else here. There's nothing more to learn from this data set. And that really got us going. Like the insights here were amazing, and the thing that is so different about this modeling approach is that it scales. Like as we add more data, as we add bigger models, as we add better compute, the algorithms are just getting better and better and better and better and better, which is very interesting. It's a unique characteristic of deep learning, is more compute, more capacity to your models, and more data is better results. They're going to diminish at some point, but I think we all underestimated how far away the diminishing point of the curve was. So this takes us to 2017, and I don't think it's by chance. Like if you're a researcher in 2016, 2015, ImageNet is like a solved problem. That's not all that interesting anymore. In 2017, Google Brain and Google Research released a paper called Attention is All You Need, and that's really where the foundation for transformers was introduced for the first time. And that's a picture of it on the right. It's pretty complex, there's no doubt about it. But this is the new hotness. Everything now is really, especially in the language models, is based on these transformers. The interesting thing is that this came from Google Brain and Google Research. Okay, so they published this research, and they're not the ones who monetize it first, right? OpenAI built on top of this, released ChatGPT. I have a feeling that, if Google could go back in time, I think they don't publish this paper. I think Google protects the revenue, sits on search, because right now the biggest threat to search is ChatGPT, right? The biggest threat to their empire is based on a paper that they released in 2017. So I have a sense that there's going to be a lot less open research coming out, and there's some irony in OpenAI. I think you'll hear some people call them closed AI because they are not open. And why wouldn't they be open? Well, they're a business. They scaled from 1 million to 100 million users in 8 weeks with ChatGPT. It's amazing. This is consumer level AI. Like these 100 million users are, well, one's me, and I'm using it just for my own personal productivity. I teach that class at JU. I don't know, 60% of the content, all my exams, multiple choice, content for slides, everything I get assistance from ChatGPT. Because it's great. It sets me on second or third base, right? I can fine tune what comes back and pick the right content, but it's such a leveling up. But you can see, ChatGPT getting to 100 million users in 8 weeks' time is absolutely remarkable. And the irony of it being built on technology or research that Google had sort of championed, there's definitely a little bit of irony there. All right, so some of the terminology. AI is such I love the word and I hate it. It's so broad. It doesn't really mean anything anymore, in my opinion. But I think when we think about it, we mostly think about the primary goal being simulating or mimicking human intelligence. And when we think about that, I think we think in a general form. We're thinking about artificial intelligence, like in general, being able to do many different types of things. Machine learning is a set of algorithms that learn from data. Okay, so it's kind of funny. Like you think about what AI is today, and all the algorithms is a function of the data they're learned on or trained on. Okay, so it doesn't know anything that wasn't in that data. So it only knows what you show it. So it learns from data. You're not explicitly programming it. This isn't an expert system where you're saying you play chess like this. Instead, you show the algorithm lots of chess games being played, and you say, you figure that out. You figure out the best approach to win the game. I'm not going to tell you. So it's definitely a paradigm shift. A lot of folks think that that all AI is ML. Obviously, expert systems is AI. That's not ML. But these terms are getting used interchangeably because in today's world, all of AI is delivered through machine learning or deep learning. And so you can think about deep learning as a subfield of machine learning that is really focused on algorithms that are inspired by the brain, which gives us neural networks. And it's also possibly a little bit of a misnomer too, because it's modeled from, it uses the same terms of the brain, but there's really no intelligence. It's everything it knows is still based from the data. So we use terms like neurons, and we like to say this is a brain, and we even have my picture here, AI. I got a picture of like a person and a brain, but it still is all based on the data that's contained or that the models are trained on. and this, anybody who's in this field would recognize this as the absolute truth, is we use AI to sell it because it's great, but under the covers we're using machine learning to build it. But machine learning that term doesn't quite sell as well, so we've all flipped over to calling it AI. All right, so the types of AI, there's narrow AI, and that is where you have a single task and you're executing at a human level, okay? And this is, you know, I want to classify those pictures into cats and dogs and hot dogs and vehicles. That is doing one thing. That system, that AI, that cannot, you know, write an email for you or write my exam for my students. It is doing one thing, and that is classifying images. Single task, operating at a human level, though. It's very good at what it does, but it just does that one thing. General AI, or AGI, that is what everyone wants to get to. And that is systems or software that can execute all tasks at a human level. Okay, I think you'll hear a lot of people right now. I'm sure OpenAI's mission is to tackle general AI. Everybody wants to get to that. That technology would be incredibly valuable. And then, of course, super intelligent AI is all tasks executing at a superhuman level. The thing is right now, as far as we know, unless somebody developed something in secret, which could be the case, but 100% of the AI that exists today is narrow AI. So anytime you got a brochure or you hear about AI in the news, just inject narrow AI in front of it. It's not general AI, unless somebody's developed that in secret. And right now, there really is no timeline for general AI. And I think, you know, this is my opinion now, but I don't think we get to general AI by using machine learning or deep learning. I don't think we're going to get there by just learning from data. I think we're going to have other techniques. I don't know what they are. If I did, I'd be working on it. But it feels to me like AGI is still a ways away, because I think we need another paradigm shift, and I don't see that yet. But that being said, even just narrow AI, you know, like I said, Google's business is $80 billion of showing us advertising. Very successful application of narrow AI. We've got Amazon selling us things. That's all AI driven. We've got probably one of the earlier consumer-based AI applications that maybe we all remember is Netflix. If you remember signing up for your Netflix account, going in and rating your shows so you get more shows like that coming at you. Even something like self-driving. Self-driving feels like really advanced AI, but it's really kind of an engineering problem. It's got modules. It's got, I don't even know how many different narrow AI algorithms looking for cars and vehicles in the lane, pedestrians, different systems, but you put all that together and it seems very advanced. But you know, under the covers, it's a lot of engineering. And the same with ChatGPT. It's not just one super smart model. The latest thinking is that they have 8 models behind ChatGPT, and they have a whole lot of engineering between when you send your prompt in to figure out which model should I send this prompt to, this text, to generate the result. There's a lot of engineering in between, which I don't think a lot of people, including OpenAI, would want to talk about, because it makes it seem more like a parlor trick. And they want to make it seem like they've got this awesome one neural network that does everything, because it's kind of a better story. But all these are really successful applications of narrow AI. So there is a ton of value yet to be generated and still be generated with these types. So everybody wants to know how AI is created, and I would say the formula is pretty simple. You need data, you need some algorithms, and you have to have some compute. So if you can get all that together, those are the basic building blocks of how to create artificial intelligence. There is a shift going on. So what's really interesting right now, and this has been happening over the last 10 years, is there's a ton of focus on the algorithms. We need to find people that they have a math background, a stats background, a computer science background. You need to program in Python. You also have to be very familiar with the hardware, because 10, 15 years ago, these GPUs, getting them installed and getting the software on top of them, all of that was very messy. It was very hard, very challenging. And so there was a heavy focus on code, algorithm, math, statistics, computer science. How do we piece this together? Kind of low level. I would compare it to something like from a computer standpoint, like a C or a C++ or assembler, just like low level activities that are hard to do at scale, and they're challenging to get people that can do all those things. Well, that is really changing. So now the algorithms, you have cloud providers like AWS, Azure, and Google that have out-of-the-box tools to help you build and models. There's pre-trained models. You might hear them called foundational models. OpenAPI are APIs from OpenAI as well as other providers. You have third-party libraries. Hugging Face and Spacey are a couple of really popular ones. And there is I don't know if it's a movement, but there is a shift where, I'd say 5 years ago, if you're doing anything in the AI space, you're talking about training. I have to go train, which means I got to get data and labels, a data scientist, I have to find GPUs, I got to piece all this stuff together. It's really expensive to do, it's time consuming, probably going to do it wrong, don't know how it's going to turn out. Just a ton of unknowns. And I would say now the shift is, well, let's just start building. What if we took a model from Hugging Face, or what if we took one of the models from Azure and let's just start with it and see how it does. And maybe we can, fine tune it or tweak it or modify it in more cost-effective ways than building it from scratch. So you're seeing that change. You're definitely seeing that shift of how AI is being created, and it's becoming easier to do. And right along the way, I would say that 5 years ago, when we were focused on people and algorithms and low-level Python even, that would be kind of model-centric AI, where our improvements are coming from better math, better developers, better coders. And the shift now is it's data. We're in the mode of data-centric AI. We know how to make better models. We take last year's best model, we give it more capacity, which is very simple, and we just go give it 5 times the amount of data. Like, that's the recipe now. Focus on the data. Better data, better data, better data, and the same algorithms as last year, and you're going to have better models. And the way that we talk about that at our business is, better data beats fancier algorithms. And if you think about that as, if you gave me a world-class algorithm, the best algorithm, but kind of junky data, you're going to end up with a failure. Your bad data is going to ruin your model. Garbage in, garbage out. But if you have really good data and you gave me an algorithm from like 3 or 4 years ago, you're going to do pretty good. You're probably going to have success because the data is what's driving the performance more than the algorithm. All right, so some of the applications real quick. So there's a concept of moving from kind of this co-pilot to self-driving. I think that's what we're all seeing. And you'll probably hear co-pilot in the context of AI quite a bit. But this is where everybody wants to go. They want to have, you want to start with AI. An easy entry point is this co-pilot mode where AI is making suggestions, but the human is doing the driving. And as AI gets more involved, you're seeing more scalability because you're going to have less humans, and eventually you're going to get to a whole lot of AI, and kind of you keep humans in the loop, but really it's the AI doing the driving, just like a self-driving car that, you got both modes. Like right now, I was driving the other day from JU to my work. I'm driving, and I saw something come up on my screen, and my car locked up, just slammed on the brakes because I was going to hit the car in front of me. So AI was the co-pilot, but it saved me from a fender bender. And I think you'll see the reverse, where you can use your self-driving maybe on the interstate, But when you get into, traffic, or when you get off the interstate, it's going to say, hey, I have to tap out here. I need my human to take over. So obviously there's trade-offs there and additional scale as we use AI in more and more places. So this right here is, this is how we use AI at our business. This is a human activity. These are our developers. They are writing code. And we use GitHub Copilot, and that suggests code as our developers are writing. It's saying, hey, it looks like you want to sort an array. Here's the Python code to sort the array. And every time it makes a suggestion, our developers accept those suggestions 27% of the time. So you can think of the productivity enhancement our developers are seeing. And this product is only 6 months old. This is early days, but it's amazing. You can say, hey, give me the Python code that does this. Boom, you're going to get it generated. It's not always perfect, but it's like starting on third base. This was something I saw recently, I think it was last week actually, was mammography was AI helping detect breast cancer, and it was, they did a retro and a prospective, and in the prospective study, they had humans and AI read the scans, and the human and AI combo increased the cancer detection rate by 23%. So to me, this is very interesting. I think back of Brian's talk last night about malpractice, and it's almost, the talk of, or the thinking of, if AI misdiagnoses something or causes a negative outcome, there's malpractice. I'm interested in the reverse too. Like, what happens when humans don't use AI systems and we miss things in the scans? I would like to say the reverse. Like, at what point as a human are you, not practicing right because you're not using the best technology? Are you a pilot that's turned off GPS when it's shown to help? I think there's interesting conversation in that area. And then this is where it gets really interesting, is where you have the algorithms have surpassed human level performance. And there's quite a few benchmarks where this is the case. In cases like these, you get a lot of productivity enhancement because you have a lot of automation. You got to keep the humans around because there's the hard examples, but there's a lot of automation gains that are here for us to take. All right, the excitement. This is actually my favorite one of the DALL-E images because of them. Like, it gets it so close to right, but what's illuminating the back of the monitor, right? It's like, it's so close, like you have it, but not quite. So Gen AI today, it's really being used in so many places already. So drug discovery, we've seen OpenAI and ChatGPT. Chatbots a year ago today have they probably had a really bad name, and now chatbots are like the best thing ever. We've seen DALL-E helping me with this presentation. The Headshot Pro is a tool I use because I do not like to dress up. I don't own a suit, but I needed a picture of myself in a suit. So I used the tool to take some of my headshots and make me look pretty, or attempt to. I've talked about the GitHub Copilot, or AI programmer, and of course, there's lots of use cases in gaming. One thing though, I think we all heard of hallucinations. So this again is my headshot. And I think maybe you guys can't see it from there. Like, from a distance, this looks pretty, well, maybe it doesn't look pretty good. That's debatable, but it doesn't look terrible, I hope. But if you look at my eye and you zoom in there, like, you got it so close, right? So close, but what the heck is that? And going through our presentation here, so I think I already talked about this one. I would have put that in different order, but man, it did a good job, got really close. This was out of one of the other slides. That person is missing a head. If you can see the purple shoulder behind there. Can you guys see that? Yeah, there should be 4 heads there, and we're missing a head. Still, it's a great effort. Like I said, it spells worse than I do. Doesn't quite get the years, so 19974. knows there should be something like a year there, but doesn't quite have that context. And, is labeled the oceans, Asia, in one of the other slides. And again, with those eyes. Yeah, I don't want to look too long at that. But the potential, and that's where I think, in these last two slides, what I would want to say is, from our standpoint, generative AI, this is the Gartner hype cycle. Gen AI is at the hype. We're at the peak. And something that has already moved into the plateau is computer vision. So computer vision is ready to be used in ways today that can really drive productivity. Gen AI is going to get there. Gartner has it at a 5 to 10 year timeline. You can look at AGI on here, artificial general intelligence. Gartner has that at more than 10 years, so that's a ways out. But like that quote says, we tend to overestimate the technology in the short run and underestimate in the long run. I think that's probably true about Gen AI. We're probably overestimating it right now, what it's going to do for us next year, but probably underestimating what it's going to do for us in the next 10 years. And then finally, I'll close on this one. So this was a slide. I'm probably not going to present it as well as he did, but this was from a hospital system, CIO of a hospital system in Jacksonville. And this is a picture of, there's a girl there who, this is a picture that she drew of herself, reflecting her experience as a patient in a hospital. And so that's her in the middle. She's on the bed, and then her mom is to the right of her reading a book, and I think that's her aunt and her sister on the side. And then the physician got her back to the patient, typing into the computer. And that was her memory of how she thinks about her time, getting care. And so to me, it speaks to the opportunity, I think, is the opportunity in healthcare is really endless. And the tools are there today to help make a difference and help change the picture of this, or the perception that this young lady had as part of her visit. And that is it. So thank you, everybody.